All right, welcome, ladies and gentlemen, to Open Live Q&A. This is week number 148, and my name is Mr. McLogan, and thank you so much, guys, for joining me in on this live stream. I am so happy to have you on tonight, and just go over answering more of your questions that you guys have. I know that semester exams are coming up, so there's definitely some more questions that have already kind of started to hit, and I kind of expect that. To kind of continue here as we get into the end of 2022. So definitely look forward to helping you guys with the exam, and I'm actually going to be planning on doing. I did this 2 years ago, and I think I'm going to try to do it again, which is going to be kind of like a little like semester review kind of thing for at least for pre-calculus, and maybe might be able to do like an algebra too. We'll kind of see how it goes. But hey, Rathor, good to have you on. And Haynard, what is it? Haynard? Maybe thinking, maybe close. Maybe let me know. Max, good to have you on. I'll go and get to your guys' questions. Alex, good to have you. Ava, Pleda, Nicole, Kent, and Denara. So good to have you guys on. Thank you so much for joining in. All right, let's go and see some of mine. Oh, Maria. Awesome. Mr. McLogan got my first 100 in pre-calc class. Congratulations. That's so awesome. What's your favorite in all of unit math? That's a good question. I think one of my favorite, it would be, I guess I just simplified to be trig identities. I really like trig identities in pre-calculus, and that was just kind of one of my favorite. Kelly Kapowski, how do you solve exponential expressions with fractions? So if you guys do have some math questions, it is very difficult for me to kind of read the chat and get into the math, okay? So the best way for you guys, if you do have a question, and I do apologize, I already got decent amount of questions, but I would definitely recommend you go there and submit it. So therefore, I have time to review the question and then write it down onto my whiteboard, because what's going to happen is I am going to get to some questions. And when I get to some questions, it's going to look like that. Okay. So you guys will see I can post everything done. It's a lot easier to go ahead and copy things like that when they are submitted. So I will leave that up there for you guys. So therefore you guys can go ahead and post up the questions. Yes, I do have some more pre-calculus. I'm actually going to get into trig this week. And hey, Yudin, help out. I cannot think of it. Well, so hard to help out. Max, yeah. Where's Max? What was Max questions? I want to see what Max was saying. This might be a stupid question, but there are any? Oh no, I don't have any chemistry. But yes, the organic chemistry teacher has a lot of great videos. I am going to talk a little bit about piecewise functions, but yeah, you can go ahead and submit those. I would definitely say that it's the hardest difficult. Trig identities. Yeah, I'd probably say it's pretty close to being one of the harder units in pre-calculus. And so yeah, it's just kind of so different for in that regard. But yeah, I wouldn't say that's why I like it, but it's just one of those, I don't know, lessons I just enjoy teaching and also doing. What is my next lesson? If my last lesson was in vertical asymptotes and discontinuity, I'm in pre-calc. To be honest with you, there's so many ways your teacher can teach pre-calculus. It's even in calculus. Like you can move the topics around. Typically we're getting into like graphing that or solving rational expressions. And then typically once you're done with that, that's usually going to be like a chapter 3. I would say you're probably going to get into trig. That'd be my guess. I'm not sure about the exact next lesson. Your teacher definitely can move that around however they kind of see fit. Hey, Justin, good to have you on. Thank you so much for joining in. Well, happy to be able to help, David. There's a couple different ways to be able to do this. If you have a specific question, I would just recommend putting it at on my bradmclogan.com/Q&A, and therefore I can kind of take a look and give you some advice there. I love it, Flicker. So I don't teach anymore at in the high school, so I just teach basically online, but I did teach at Mandarin High School. Right? Do you have any videos on literal equations? Yes, I do. I probably have over like 100 on literal equations. So if you just go and type in you can go to my website or if you go to my YouTube channel and just go and look for that playlist under Algebra 1 or look under my playlist, you'll see literal equations. I have a ton of them. What do you mean by you're going to be free tutoring? Yes, I am. Well, I am going to be doing something looking for students that need some tutoring or coaching up to their semester exam. So I am going to be doing something like that. If that's what you're asking for, I'm not really sure what else you're meaning regarding the free tutoring, but yes, that is something I am looking to do here. Um, yeah, there's a lot of different like variations, from the class one, but general mathematics, it's kind of hard. But well, I'm glad to hear that you're getting the hang of it though. And hello, everything science. I like rocking numbers. Great. I'm assuming I don't know if you're talking to me, but yeah, I did go to college. I went to Western Michigan University, and that's where I got my degree to be a teacher. I totally taught inside the classroom for 14 years. So I stepped away. Last year was my first year away. So this year is my second year away. But I am now going back into the classroom and doing some like student teaching and stuff like that, which is kind of cool. Not directly SAT tutoring. I am going to plan on doing some more, I think, with like the SAT, like doing some problems and stuff like that. But I'm not doing anything directly with SAT tutoring. Yes, I have a ton of videos on rational exponents. If you guys just go to my if you guys go to my YouTube channel and just go to like the playlist section and just type in whatever you're looking for, typically whatever you're looking for, I have a ton of examples on. Obviously, if you're looking for larger topics, like very broad, basic topics, obviously there can be some very special types of problems that I might not have a ton of examples on, but I have over 12,000 videos, so I do have quite a bit of examples. Oh, hey, Rona, good to have you on. And yes, can you clearly explain what a reference angle is? Yes, the reference angle is the positive acute angle between the terminal side of an angle and the x-axis. That might not be clearly, though, for you. So here's another way to kind of explain it. It's the distance from the angle to the x-axis. And whatever that distance is, just it's always positive and it's always acute. So it can't be larger than 90, it can't be 90, and it can't be 0. So it has to be between 0 and 90, which means acute. We're always just represented as positive. And basically, like whenever you draw an angle, just find the measure back to the x-axis. That's going to be acute. And whatever that measure is, that is your reference angle. Just remember it's always positive. So it doesn't matter which direction you're going, clockwise, counterclockwise, doesn't matter. We always measure the reference angle as positive. And I do have some more videos that will come up that I'm talking about. And actually, I think I have that video as well, too. So that I don't have anything. I know I don't have any recommendations. I mean, I have a lot of math, but I always like, I think recommending math books is kind of difficult. Like from what I have experienced, like a lot of math books can, no. Reference angles are acute. They have to be acute. They are the distance from the terminal side of an angle to the x-axis. Those are going to be your quadrangles. So those are not reference angles. Reference angles are positive and acute angles. But if you have a specific question or an angle, submit it into there. So therefore I can post it on my board and it'll be a little bit easier for me to explain. But yeah, as far as the, like math textbooks go, my recommendation would always just like look at a couple, or at least hopefully you have access to a couple that you can kind of review. And I just don't have any recommendations, but I would say that, you can definitely, it's actually surprising how different some math books are and how much one can be much more helpful than another. So if you buy a book or you see a book or you borrow a book or whatever, and you're like, oh, this is going to be way too hard. Like, don't give up. Like maybe try to look for some different books that maybe give you better examples or have easier or harder solutions to help you out with, right? Like I had a student that was taking one of my math classes or my math course, and they wanted more difficult problems, right? And sometimes people I wanted more easier problems, right? You're never going to satisfy everybody. So obviously each book is going to be tailored for, for a different subset of students. And so, one of those things you're just gonna have to kind of like explore, take a look at to see if it's going to be the right fit for you. Hey Ethan, I'm glad to have. Actually, that was one thing I gotta go and actually see what the score is. Because obviously living in Florida, I don't get to follow my Lions, or at least I don't get to see them on TV all the time. But I wanted to actually check the score, and I forgot to do it. So thank you so much for that. What is the most difficult algebra question? I don't know. There's a lot. A radical is just going to be there's a lot of different explanation for there, but it's like Ooh, Detroit won by 1. Awesome. So, yeah, I'd have to probably go through that, but yeah, I mean, it's basically something being multiplied by itself to get to that radical from on there. That's really bad explanation, but I'd probably have to be able to. Probably not something I can take. Just look at. I wanted to get back to this comment that I saw, so I was trying to go from there. But you can think about it as the inverse operation of a power. Okay, not really a power. Yeah, it is the inverse operation of the power. So best advice for a first year math teacher, love your channel and watch a lot of your videos to transfer to my students. Well, awesome. Very, very happy that, some of my videos have been able to help. I think, you know, my advice for a first year teacher, or just really, any teacher is, just remember that, um, remember that the, um, there's a lot of different things that I have. Remember that your goal, one of the things that you need to do is make things engaging, right? And powerful. Like you are battling now students that have their phone and everything else. Like, and again, like, not to say that you always have to make math like the most interesting thing. Like there's a lot of times I just told my students, this is going to be a boring lesson. We need to get through this, blah, blah, blah. But I think what my point is, always look for opportunities or always look for ways that you can teach the content that is going to encourage, motivate, and build that curiosity for the students, right? I think it's very easy for us to sometimes just fall back into, here we're taking notes, or here's how I taught it last year, or, whatever else. But I always think about, every year I always try to like improve upon my lessons. And every year I always want to think, I was like, what is something different I can try this year that one is going to be more exciting and engaging for myself, and then also for my students. And I think that, I think just, always kind of be in that mode of like, just keep on trying things, and have fun with it. Have fun with the students, have fun teaching the content. And, I guess one of my biggest advice to go from there is just, one, there's going to be a lot of ups and downs, right? But, just be, just remember you are, to enjoy like creating those lesson plans. And I think that's the one thing that we can still kind of hold on as teachers is creating good lessons that students want to show up to, right? Yes, students are required to show up in class, but again, they can still show up and not really be engaged, right? So try to think about really kind of creating those lessons that students that you are excited to wake up and go and teach, right? Not just something you're just doing to collect a paycheck. And, that was kind of where it got to that point where, after 14 years where I realized I needed to step away because it was really difficult for me to create my lessons. And, it became really hard for me to be able to create my lessons where I was excited to be teaching and engaging with my students. And I just realized I'm like, that's not the teacher I want to be. Like if I can't make this exciting for my students and for myself, like I got to get out of this profession because I don't want to be that teacher. And, that was one of those big reasons why I decided I needed to step away. And, so not saying, and again, that was after, 14 years, like there was many, many times, many, many years, I kind of felt like I had those kind of feelings, but it's like you, um, it's, I don't, I, it was, that was one reason, as I mentioned, there's many, many other reasons that, factored into my decision. So it's a long road, there's going to be some great days. There's going to be some bad days, there's going to be some good years, some bad years. But just remember, I think another piece of advice, which I really am taking a long time on this question, is just remember why you wanted to become a teacher and try to infuse that into your daily lessons and into each and every year, right? Because that's what we need from, teachers like you are that have that enthusiasm and engagement. And I hope that anybody else that's a teacher out there or a parent can kind of relate or have that infused with their, teachers. That's what we want for our children, right? We want the best teachers to encourage and motivate our own students. And we want people that enjoy, teaching math and also just enjoy teaching our children. So anyways, hopefully that was helpful. Please give me a glance on this on this. I'm not sure. Did you give your students pop quizzes? I hate when my current teacher gives them. And no, I maybe once in a while I used to give them, but not very much. And if I did, students would always have an opportunity to like fix it and create it up to. Yes, I do like trigonometry more than logarithms. Do you believe in memorizing formulas? Nope. I used to always give my students the half angle formulas. I gave them all. I never made them memorize those things because I would forget them every year anyways, right? So like it took me, even I think there's even one on here. Like, I mean, my main advice for memorizing things is do it over and over and over again, and it just becomes more, it's easier to understand from there. Okay, so this one's kind of it's a difficult thing to understand. I guess my main thing I would look into, like the main ideas you have to understand from this is, or at least to kind of give you an idea, like remember sine and cosine, they're like plus or minus, right? So you just gotta look at like what quadrant is the half angle in? And if the half angle is in the first quadrant, right? So again, that's gonna be anything between 0 and pi halves, then it's gonna be positive for both sine and cosine. The only time that cosine is going to be negative is when the half angle is in the second or the third quadrant. And the only time that the sine, half angle of the sine function is going to be negative is when the half angle is larger than pi, right? Which it means that's going to be in the second and the third quadrant. So those examples are very far and few in between. But you just got to remember, like if you're evaluating a cosine and it's in the second quadrant, it's going to be negative, right? If you're evaluating cosine and the angle, the half angle, right, is in the third quadrant, then cosine is going to be negative, as well as sine will be negative. There's just not a lot of those examples. So if that doesn't make any sense to you, I would just maybe assume that the value is going to be positive, unless you see that half angle. Like for instance, I just got to write this down. For instance, like if I said, here is my, if I said like the cosine of 11 pi over 12, right? And I said, all right, that's the half angle. Okay. Well, that's going to be in the second quadrant, right? So that's going to be negative. The sine though would be positive, right? But what if I said like the sine of, 13 pi over 12, and that was the half angle? Well, that's going to be in the third quadrant, right? So therefore sine would be negative. So just a quick little point to kind of see, like, just know where that quadrant is of that half angle. That's kind of your heads up, from on there. All right, let's try to get caught up on these questions because I do have some math questions. Do you allow students to submit outputs after the deadline? Not sure about the outputs, maybe like test corrections. And I mean, it's always a case-by-case basis. Everything's like that. I didn't see the score. I don't know. Go ahead and submit it to brianmclogan.com/Q&A, and we'll go and take a look at it. How do you determine the equation of a radical function from domain and range? Well, that's good. I seem like there could be many, many different variations for that, though. So I think that might be a little bit different. I mean, yes. I don't really think that's the best way of kind of teaching it, but yeah, I mean, you can kind of think of it that way a little bit. Can I pay you to fly to North Carolina? Probably not. Well, you can, but I don't know. I mean, for things. Yeah, I did resume tutoring. I am going to be doing I'm just offering my free tutoring, the assignment from on there. So, yeah, I am going to plan on doing, actually, you know what? Let me see, I didn't have that. Let me go and see. Since everybody's on, I guess I might as well maybe post, but I'm going to kind of do something, just a reminder for those of you going through. But yeah, if you are looking into some private tutoring, I do have a little option, free tutoring opportunity. So you guys can go and check that out. Might be something that some of you are interested in, but that's all I am opening up from this regard. Yes, I do. If you just go and take a look at my channel, you'll see there's plenty of stuff from calculus on there. How would you tutor math to a fourth grader online? I just realized that one of my kids that I tutor doesn't even listen to me and watches anime on the side. I have no idea. That's a elementary, anything like that. I just wouldn't know. But that is something very interesting. Addie says, do you have any videos on how to factor polynomials? I have a ton of videos of factoring polynomials. Yeah, I mean, it just comes down to guys practicing, studying, asking questions, getting help. I mean, unfortunately, there's just no real, like very tips. But if you have something specific, let me know. But I mean, it's a lot of it's just very basic stuff that you guys are aware of. Well, absolutely have to help. I have no idea. I mean, there's a ton of hard math questions. Just make sure you're doing the work. Calc 1 and Calc 2, it's a little bit more of a step up. So it is going to require a little bit more. I think you got to be a little bit more prepared. Even if you did well in Calc 1, don't, I think sometimes students feel like, oh, I overcame Calc. They feel like that's the pinnacle. And then they feel like Calc 2, they can kind of relax. Don't relax. Calc 2 always struggled with much more than I did with Calc 1. So for most students, you still got, you're going to be tested. So, keep on getting ready for that. I mean, depends on the equation, but if you're just looking at the parent graph, with one logarithm, then no. I've been binging your videos for hours studying for the college placement. Turns out I forgot a lot of stuff. Yeah, well, that's okay. Congratulations for keep on working on that. And yeah, there's nothing wrong with that. Keep working hard. You're very welcome. Well, nope, I gave them to all my students all the time. Yes, gotcha. Good job. I really love to keep up the good work. Thank you very much. My math teacher wants me to memorize. I'm so sorry. Sometimes I used to make my students do it as well. Like, I don't think it's like the worst thing in the world. It's just like a useful thing to make student, it's not really helpful. But my recommendation though, I would have, for you is just practice writing them down, practice using them in problems as often as you can. And then, and it makes it'll make things a little bit easier for you, I believe, to recall them. Because once I teach something, over throughout the years, like after or as I'm teaching inside the class, when I do it multiple times, the more I do it, then the more it's easier for me to recall it. Well, awesome, Nicole. Happy to be help. I'm taking college algebra and going to be in pre-calc. I'm not good at math. Sorry. No worries. No, I was not very big fan of math. Submit it. Submit your question. I would say factor out of 3 though first. It's probably the best thing. I mean, mapping notation is usually just going to be like from mapping. Like we usually a lot of times do that from like domain and range, from on there. But yeah, I'm not sure how you find it. Typically we're given like a mapping question and have to answer questions from on there. All right. Do you think that going from a good public school to a prep school will mean harder math classes? I think it's all relative to the class, to the school, and to schools you're going to. I don't think it being public or prep in general makes much bigger a difference. Or really can be. There's a lot of variables at play. I have an exam tomorrow. Well, best of luck for the first trimester, and you popped up in my notification. What a coincidence! Well, come on, let's get in. This is this time. Hey, Nishant, good to have you on. Mr. McLogan, I got my Unit 2 math test back, which was in Algebra 2 stuff, and I got an A+. Thank you. You are very welcome. That is so awesome. All right, well, let's go and get into some questions. Let me go and see. Did anybody... Oh, I got 3 more questions. You guys got me in. Okay. All right, so I'll try to get to 3 more questions. I don't know if I'm going to get any more onto that. Tips for related relates. I think from related... you got to make sure you're, setting up the equation. I think that's just really like, to me, it's the most difficult thing is like setting up the math, right? And then once you have the math set up, then you're basically kind of good from there. So, I think my only advice would just be doing more and more practice problems with related rates. I think the more and more you do, you kind of notice that a lot of the calculus problems are going to be very much related to each other. And then, yeah, for most calculus topics, that's usually what it takes is doing quite a bit of practice from on there. You're happy to help you out, right then? How many should I do math a day? It all depends on what course and what you're trying to get out of it. I think at a minimum, we should be looking at least like 15 to 30 minutes if you're just in a general class. And obviously, if you're like a math degree or doing something else, there could be more into that. But I think if you can just try to be consistent with like 30 minutes, even doing review or doing your homework, like at a bare minimum, I think that should be good. I'm not aware of a mapping notation formula. At some point in your life, did you want to be a university professor? Yeah, I did think about it actually. But I did think about it, but then I kind of realized like unless you actually are a legit professor, you're just going to be mostly stuck with like generic classes. And then I was like, all right, well, that's kind of like going back to high school and realm. Like that's where I kind of got burnt out teaching algebra 2, and pre-calculus. And basically if I was going to be like an adjunct professor, unless I'm doing something heavy in math, I'm probably just gonna be teaching like college algebra, pre-calculus, and calculus. So, I just wanted to kind of go back through some more courses and some more stuff and like just kind of have more of that flexibility. And I kind of felt like I think being tied down with a school would kind of limit that. Um, I always use GEMDOS or PEMDOS. It's easier to understand. But you can definitely make the mistake with grouping symbols, GEMDOS, and also even GEMDOS can get like even exponents is really not that great from in there. So it really just depends. Thank you, Bolt. Do you literally how to go to math? Well, thank you so much. I'm so happy to help you out. Could you organize your contents? Well, I have over 12,000 content. If you've kind of already seen a lot of my new content, I am producing exactly in that order. So unfortunately, it might not be exactly what you're looking for, like for this year, but hopefully within the years to come, you'll see how things are going to be following a certain path. So I'm hoping that it will be helping you out. All right. All right, guys, let me go and get into some math questions. I will still be answering questions that you guys have, but I'll just try to like see things on the chat. So feel free to keep on going on from there, and I'll try to add them best I can. All right, but if you guys do have any math questions, again, you guys can go to brianmclogan.com/Q&A. All right. So how do you cope with engineering lectures with literal poor information? So this is one thing that I thought about, like when you guys have a poor foundation, math skills, like you just got to remember, like go back over the like you have to consistently. That was the one thing that students say when like, how much math should I be doing tonight? Like if you have poor foundational skills, let's say you're doing, I don't know, 30 minutes a night, like you should be focusing on like 15 minutes or like at least a quarter of that. Even, 10 minutes or whatever, 7.5 minutes of just working on like prior skills, like get some foundational stuff, go back to fractions, like factoring, whatever it may be, that you have that poor foundation on, like go back to algebra 2 content, algebra 1 content, like pre-calculus content, and just practice some of that stuff. Like you have to build up those foundations, because if not, that's always going to be your crutch. So, I'm really happy that you understand that you are, it's hurting you and it's like building up that fear and stuff, but just understand like you can improve upon your prior foundational skills. So just keep on going back at it and work at it, and you got this. This student says, I really feel like I rely too much on my professor's study guides, and I'm scared that I'll have a teacher that won't give me much to study with, like give me practice rounds. Yeah, I totally get that. I think a lot of students sometimes, they really get comfortable with their own teacher and how the teacher prepares them for their test. And that's one thing that like sometimes I would feel bad about, when I would give my students, like I would give them, pre-calculus, they would have like 3 or 4 versions of like my test, old tests, right? With all the answers, videos of me working through them. And I'm like, not every teacher is going to have this available for them. And some students did struggle, right? They came to another teacher and they're like, holy crap, like, they might not have studied as hard as I wanted. They might have like gamed, figured out a little bit more and gamed the system maybe a little bit more for me. And maybe didn't put in as much time and effort as I wanted them to. So I mean, I think that is a worry. I think though in the end, like I want to make sure I'm teaching my students how to be prepared and like how to practice. Like you don't need your teacher study guides. Um, you don't need them to be a great teacher or their notes or anything like that. Like I would just recommend, you got to understand, like you got to take control. Like your teacher is always going to change. All those things are always going to be different. So, I would, I totally get it. And I can relate to it from there, but I would just, try not to maybe take a test and like try not to try to find a little bit more resources or do a little bit more practicing on your own. That's not such a reliance on there, because yeah, you're right. Like that, that could come back to bite you if you are just trying to game the system, from on there. But in the same respect, I would just use it for what it is and adjust as you need to for next classes. Like every teacher, every course is always going to have like an opportunity, I think, for you, right? So I don't feel like I don't think you need to be like an end all be all, from on there. Kelly, I have a ton of Algebra 2 playlists. Just go to my channel, go to Algebra 2, and you'll see all the playlists. I always maybe thought I'd be like a architect or a construction worker. I don't know, but maybe one of those two. Well, thank you. All right. So let's go and do some math questions here. So this one, hopefully you guys can see these. Trying to make it a little bit bigger for you guys. All right, let's try to get these. These are some questions. I think they were submitted last week. I apologize. I wasn't able to get to them. So BD bisects, all right, ABC, and measure of angle DBC. So D to BDC is equal to 79 degrees. So this is 79 degrees. This whole angle, A to B to C, is a 9x minus 4. Okay, so a couple different ways we can do this here. If that's 79 degrees, then that's going to be, this one's also going to be 79 degrees, right? That's the definition of bisecting. So we could say 79 degrees plus 79 degrees is equal to a 9x minus 4, right? Because these two are going to add up from in there. Another way you could also do that is you could say 79 is equal to 1/2 of 9x minus 4, right? Because if something bisects, that means it cuts it in half, right? So if half of that is 79 degrees, then you can go from there. Either way that works. 79 times 79 or 79 plus 79 or 79 times 2, I'm sorry, is going to be 104 to 158. So it's going to be 158 is equal to a 9x minus 4. And then we'll add a 4. Add a 4, that'll be a 162 is equal to a 9x. Divide by 9, divide by 9. Let's see, 9 goes into there. Let's see. We got that'd be 10, that'd be 90. And then we could do, I don't know, my brain hurts. I don't want to, I'm not going to think about this. Shouldn't be, that'd be 10. I don't know, why is my brain giving me a brain fart? 18. There we go. Yeah, 18. So x is equal to an 18. All right. The measure of angle G is 6 more. So angle G, I don't know what my G's look like. So we'll call angle G is 6 more. Okay, so plus 6, then twice the measure of angle H. So we say angle H, so 2 times angle H. If G and H are complementary, find angle H. So what does it mean for complementary? So that means angle G plus angle H is equal to 90 degrees. Okay, so in a problem like this, what you're going to need to do is use is to kind of use some substitution, right? So I can say that a couple different ways you could do this. But one thing we could do is we could say angle G plus 6, right, is equal to 2 times angle H, right? So we can set up an equation here, right? And I could subtract a 6 here on both sides. So I can say angle G is equal to a 2 angle H minus 6. Now, why is that important? Well, the reason why that is important is because now I can plug in this value for G in for this value G, right? Because just substituting in the value. So therefore I can say 2 angle H minus 6 plus angle H is equal to a 90, right? And again, we're trying to solve for H, so this is going to be perfect. So this is going to give me a 3H. Let's add a 6 to the other side. So 3H is equal to a 96. Divide by 3, divide by 3. H is going to be a, 32. So angle H, forgot those angles. Angle H, divide by 3. So angle H divided by 3 is going to equal, so that's going to be a 32. Right? Hopefully. Yes. Check my work, please. I think I'm doing everything right. This one says, if measure of angle DEF, so DEF is 170 degrees, find the value of x. So therefore, we know that these two angles add up to give you 117 degrees. So therefore, we can say the measure of angle DEF, or actually, what we can say actually is this plus this equal, oh yeah, so let me just write out this statement. So I can say angle DEF is equal to angle DEG plus angle GEF, right? So therefore I can say 117 degrees is equal to a 12x plus 1 plus a 5x minus 3. Then you can just combine like terms here. Say 117 degrees is equal to 17x minus 2, right? So then I can add a 2, and I can say 119 is equal to a 17x divided by 17, divided by 17. 119 divided by 17 equals 7. So x is equal to a 7. Oh, come on. You guys give me 7 more examples, 7 more problems. Oh, come on, guys. Let me see. Somebody blowing up the thing. No, I guess it was the same one. All right. Well, we'll try to get to these questions. We'll see. All right. If you were given an equation, so this one was kind of confusing because there's not really like, I'm not really sure what this student was asking from this, because like if you have 2x, like x minus 5, right? And like, I don't know, the equation could look like this, right? But again, like if you have 3x, like there's more than one answer for C, okay? And I kind of played around with this problem as well. So I'm not sure how where this question came from the student, but there's more than one answer for in this. So what I did was if you want to kind of get one answer, or a way to get an answer, okay, this is not the only answer. This is a way to get a answer. So if I had x squared plus x, minus 5, and I said it has to equal to a 3x plus c. Okay, boom, has to be. Now what I did here is I just subtracted a 3x. So I got an x squared minus a 2x minus 5 equals c. And I said, all right, what I want to do is I want to make this factorable, right? So what I thought about was well, if I had a x squared minus a 2x minus a 3 equals 0, that's factorable, right? So it could be a x minus 3 times an x plus 1, right? So therefore, it'd have those two intersection points. So therefore, I said, well, what value is going to make c is equal to -3? Well, I said when c is equal to a -2. So when c is equal to -2, this actually works. This solution works. However, there's multiple other answers for this. So this isn't the only one. It's just a solution. All right. So I'm not really sure exactly the context. This is just all I got for the student. From the student. So hopefully that will give me more context. All right, so prove. So this is going to be a difference formula, right? So again, remember I was talking about like the students like memorizing these formulas. So this is helpful. You guys need to know these formulas. Well, you don't really need to know them, but you should be familiar with them, especially if you're taking a test or a quiz on this. So this one's going to be the cosine of pi halves times the cosine of u plus the sine of pi halves times the sine of u. And that's equal to the sine of u. Okay, so again, this is the difference formula for, this is me applying the difference formula for cosine. So the cosine of pi halves, though, guys, is going to be 0, right? So that is going to be cosine of u. Sine of pi halves is going to be 1. And therefore, you can see that just goes to 0. So you're left with a sine of u is equal to a sine of u. Done. All right, so this question, the student was asking, I think, the student was only asking, like, how do I find P, right? And so the problem is, like, so they got this, right? Good, they got that. The problem is they couldn't find, you got to find a point for X and Y. So what you need to do in this example is, I don't know why they put this X-axis up here. Let's just pretend it's down here, okay? And so they say, like, because that's at the base, right, of this arc. So what you could do is, like, do 598 divided by 2. Right? I think that's what, 299? So you could say that here, this point is 299, 0, right? So then therefore that's an X and that's a Y. So now what you can do, you can now plug in those for X and Y. So you could say X is going to be a 299 quantity squared minus a 4P times a 0 minus a 625. Oops, sorry. What happened there? Equals. right? So now what I'm doing is I'm just going from there to there. So plug in the 299 common 0 for your x and y, right? Because again, that's going to be half of it. And over there is 299. Like that's 299 to the left and 299 to the right. So therefore now you can go ahead and solve for P. So actually, let's just figure it out. Let's figure it out. 299 squared, it's going to be 8,904.01. Okay, is equal to a negative. So that's a negative 4P. So wait a minute. 0 y minus k. Yeah. P. That should be 0 negative. Oh, that should be a plus. So that's wrong because that's a y minus k. Y minus k. No, that's going to be correct. Okay, I'll have to go and take a look, but something's negative. There's some mistake I'm making. Something's happening. Because this would be a negative 4. This would be a negative 4 times a 625. And this would be 2,500. That's going to be a positive, and it's not supposed to be a positive. I'm not sure where my mistake is. If anybody's seen it, I feel like there's something that's wrong. And I'm not sure if it's your equation that have here, because your P should be a negative P because it's opening down. But anyways, let's go ahead and do 89,401 divided by 2,500. Math, fraction. And yeah, we can just reduce that to, that would be your reduced fraction. So P is equal to 89401 divided by 2,500. However, that P is actually going down, so that should be a negative. So I'd have to go back and review the x minus h, y minus k. So that's 0, 625. H and k, so that's correct. And then your x, so it doesn't matter if you do a negative or a y, and that's going to be a 0. That's bugging me. I'll have to go and see. All right, I'll just have to move on. I'll have to go. Did I have that? Oh, maybe I'll have to go and take a look from there. So this one says express the following function as a piecewise function. Absolute value. Oh, this one I had to go and take a look at. So anyways, your piecewise function. So ARF, I believe you gave this one. So you basically want to have the absolute value for positive and negative, right? So we're going to have you're going to do a 3x plus 5, what I would do as x plus 3. And then you're going to have a 3x plus 5, where x are negative x plus 3. Okay, so those are going to be your two functions, right? Or at least that's what I would go for, start at. Now, the problem is, though, remember a piecewise function, you got to go to the left and to the right. So where should this graph change, right? So this function has to be continuous. So you got to find a value where the function is going to be continuous in that regard. And this is where it kind of gets a little bit kind of confusing. And it said do not use to graph it, therefore you have to use a table, which, that's fine. I think for my value, what I was looking at is there a value that they share, right? And what I notice is when x is equal to 0, they both have 5/3. That means when x is equal to 0, that's going to be the y-intercept. So therefore, you could just graph this. There's multiple different ways you could do this, but you could say x is going to be greater than 0 and x is less than 0, right? And then what you're going to need to do now is just plug in values that are going to work to kind of get an understanding of the shape of the graph. All right, so for x is greater than 0, I just plug in 1, 2, and 3. And x is less than 0, I do -1, -2, -3. But that would be an example that you could do from that. So hopefully that is helpful. This student says proportions as similar triangles. Okay, so this one looks like we have a trapezoid, find proportionality. So we have, the main thing is you got to go big to small, right? So the big here is going to be a 14. And then the big over here is a 21. Now, the small is that we're dealing with is going to be a 10 and then your question mark. Okay, so what we can say is, I mean, multiple different ways you can do this, but you can say 10 is to 14 as x is to 21. Then you just go ahead and, apply your cross product. So you can say 21 times 10 is 210 is equal to 14x. Divide by 14, divide by 14, 210. Divide by 14, x is equal to a 15. And that is going to be your missing term. All right, let's see. That is all the questions, or at least that were submitted. So I know many of you added some extra questions. So let's go and see what we got here. All right, 15, I got that one. All right, how would you factor? This one is tripping. Oh, I mean, that's not going to be, that's not going to be factorable. Let me see. I don't think that's going to be factor, at least. Come on. All right, so let's see. Yeah, that's not at least over rational numbers, is not going to be factorable. So I'm not even going to attempt doing, or I'm not sure what you would want to do with that. Sorry, Alex, but that was that factoring problem. How do you find the focus in the directrix? Okay, well, that's getting back into my... Oh, well, that's why. I know what she's saying. Okay, that was already negative. Yeah. This actually the equation is not negative. That's wrong. That's supposed to be a positive. It's positive. Positive. Therefore, P is equal to a negative that. Because that's supposed to be a negative 2,500. Thank you. So the equation was wrong. Whew, I was wondering about that. I'm like, God, this is crazy. Okay. All right. So this student says, how do you find the focus and the directrix here? So let me go and steal their question. This is why I have you guys upload them. All right. So remember the formula is x minus h quantity squared equals 4p times y minus k. Okay, so we got to put in this format, right? So we have y equals a x minus 4 quantity squared minus 3. So what I'm going to do is add a 3 to both sides. So I get a y plus 3 is equal to a x minus 4 quantity squared. Now I got to remember there's a 4p in front of here, right? So I can rearrange this. This x minus 4 squared is equal to a 1 times a y plus 3. Okay, technically you can put the 1 in. Now again, remember the 4p is equal to 1. So you can say 4p is equal to 1, divide by 4, divide by 4. P is equal to a 1/4. All right, we got that. The vertex, focus and directrix. All right. So now let's go ahead and see what we know about this graph. Okay, so we know that has a x at 1, 2, 3, 4, and then y is at -3, so 1, 2, 3. Okay, so there's my vertex. We know the graph is going to be x squared, so we know the graph is going to be opening up. Right, now what's important about this is we know that the focus is going to be inside, right? We know that's the focus, and then this is going to be my directrix. Now remember the distance from my vertex to my directrix, right? This is going to be P. Right there. Okay, so all I'm simply going to do is add 1/4 to my y coordinate of the, so I can say of my vertex. So I can say the focus is equal to a, let's see, that's going to be a 4, 3 plus a 1/4. Now, how do you add 3 plus 1/4? Well, just rewrite 3 in terms of force. So that's going to be a 12 force, right? 12 divided by 4 is 3 plus a 1/4. So therefore, that is equal to a 4 comma, 13/4. And the directrix, you're just going to subtract, so that'd be an 11/4. But remember, that's a horizontal line. So therefore, that's going to be y is equal to a 3 minus a 1/4, which is going to be an 11/4. So y is equal to an 11/4. And voila. I just want to say thank you. I'm happy a 7-year-old who tries to help his grandkids. Oh, awesome. That's so great. Well, thank you so much. I love that. Yeah, using parent graphs is going to be the fastest way. That is a very loaded question. I do have actually a video on that might be helpful. That might answer your questions maybe a little bit, but there's a lot to that, a lot to unpack. A lot more than I can just, I think giving you in 2 seconds to help. But I do have a video about how to get motivated in math. Maybe that might be helpful for you. You can just search, McLogan get motivated on my channel. Hopefully, and maybe I'll be helpful for you. All right. Let's see what else we got. I'm a pre-calc student as a freshman, and what would I do for my next 3 years? I have no idea. Probably calculus, statistics, maybe go take some dual enrollment classes, but definitely speak with your math teacher, speak with your guidance counselor, talk with your parents, see what is going to be the best route for you. Everything's kind of variable. It really is. No, state the value of x where the function is discontinuous. So the thing is, so what the student is asking is about like tangent. Okay, so we want to know when tangent is going to be discontinuous. So, kind of getting to that point that the question that a student asked was like, how do you like graph your functions like easily? Knowing really the parent functions is really helpful. It really is. So, and that's going to be the best advice I can give you. Okay. So state the value of the function where x is discontinuous. Now, this one I can actually give you a different explanation here. Okay, because most students know what tangent looks like. Most students. Most students that at least have learned trig. Okay, now we have these nice little asymptotes. And what happens though is this graph keeps on repeating and these asymptotes keep on repeating. You might say, well, where are these asymptotes occurring? So what we need to do is understand the unit circle. Okay, so, and specifically in the unit circle, we need to understand these 4 points. 1, 0, 0, 1, -1, 0, and 0, -1. Okay. Now remember, these are going to be your coordinates points as x, y. Now remember, tangent of any angle is equal to a y over x. So whenever x is going to be 0, the function is going to be undefined, right? So you can say at pi halves. You could also say at negative pi halves, right? And guess what? That's what the first 2 asymptotes are. Pi halves and negative pi halves. Now, you could go in the positive direction, which would keeps on meaning going in this direction. I don't know why I'm still using red, right? So you can keep on adding them up, or you can go in the negative direction. But either way, I want you to understand, to get to the next asymptote, you have to add pi. To get to this next asymptote, you have to add pi. And again, how many times could you add pi? Infinite many times. So the way that the asymptotes work, where the function is discontinuous, is you could say tangent of theta plus pi plus pi. Or you could go in the opposite direction, plus a negative pi, right? So it could go in the opposite direction. So everything is in terms of pi n, where n can be a positive or a negative number. So the function tangent is discontinuous when x is equal to a pi halves plus a pi n, where n can be any integer. It's kind of a confusing topic or subject. Gets a lot of students, mixed up when we get to it. You're one of my favorite channels. Quick question. What are the main differences between Calc 1 and Calc 2? I finished AP Calc AB. I mean, there's not a lot of difference from there. I mean, obviously you're going to get into a little bit more different, more. I never taught Calc BC, by the way. So, but you are going to get into, I think the sequences series, you're going to get into, actually, I can't even remember. It's been so while since I was even teaching that I remember the differences from there, but there's just only a handful more of topics. that you're learning in the BC curriculum compared to the AB. So when you're taking AB, there is a lot of review, or BC, there is a lot of review of the AB. And the way that we taught it in our school was we actually taught BC with AB. So they kind of like, they just went at a faster pace. Word problem. Sorry. That's probably just not going to happen. They just take too long from on there. That is a good word problem though. I'll maybe actually come back to that. I just don't have time for it now, but I won't delete it. I'll go back and review it because it's not a horrible word problem. Why x by 0? Okay, I'm not sure I understand that. I think it's just it's actually not a sticky note. It's actually a piece of paper from one of my, from my daughter. And so I actually gotta like redo on that, redo my whole back end. It's just actually a partial. And Mickey, Mickey. Graph. Okay. If you guys, again, remember you guys have questions, you guys can go to that. And guys, all the math questions, go ahead and submit them to brianmclogan.com/Q&A. It's in the description of this video, as well as in the live chat. I think I put it in there at the beginning. All right, so let's go and take a look at this one. Come on. All right, screw it. So on this one, there's a couple different ways we need to understand this. I think the main important thing here is we can understand this 1/3 as y equals 2 times a 3 to the negative first power, okay, of a x plus 2 minus 1, okay? So what you can do is you can rewrite this as a 2 times a 3 to the negative, and then you can have an x plus 2. Okay, now why is that important? Well, because a couple things we need to understand here. When I have y is equal to b to the x, okay, that parent graph looks something like this. Okay, that's what that parent graph looks like. Now let's go and include the transformations. Y is equal to an a times b to the, let's see, a c or x minus, let's just do, I don't know what, a bx, a to b, let's do a c times x minus h plus k, I guess. There's many different things, but so what's happening here is A is going to be vertically stretching or compressing the graph. It's also going to change the axis. So if this number is, or the y-intercept, if C is negative, or whatever you want to give this number, that's going to be a reflection about the y-axis. And then H and K's are going to be your shift left or right. So what's happening here is this graph has a y-intercept of at 0, 1. Okay. When we have this 2 here, that's going to shift it up to 2. All right. Now the graph is being shifted 2 units to the left. So it's going to go there, and then it's being shifted down 1. Okay. And the graph is being reflected about the y-axis. So it's going to look something like that. Okay. And remember, there is a horizontal axis there. Again, I'm at the end, guys, so I'm just kind of doing a quick little review for you. But the main thing is like, this is 0, 2 because that 2 in front. Okay. This is reflecting the graph. So y is equal to a negative b to the x. You got to just know all these transformations. That graph's going to look like that, right? If you have y is equal to a 2 b to the x, that graph now looks like that. Okay. So then what happened is this plus 2 moved it left 2, and the negative 1 moved it down 1. So that's kind of how, it was a lot to go through. All right. Let's see, we got, what else we got here? I just want to know the steps on how to complete the first part of the problem. Was it Slowfield? Yeah, that's a great question. I'd love to go through it, but it's been way too long since I'd go through it, so it's just not. It's something that's just taking me a little bit longer. So I apologize for that, Michelle. It's not something I'm going to be able to go over, at least on the live stream. Apologies for that. And all right, so I'm going to go and keep that in there. Ladies and gentlemen, hope you have a great week. And go check out the links that I posted in there. I'm going to be opening up some tutoring as well as some opportunities to get you guys prepared for your semester exams. So hopefully that's going to be helpful. And hopefully you guys have a great week. I'll see you guys next week. Cheers.